Hi there, I'm Christian Hohmann, your host and a big fan of the logical thinking process. You may have watched some of my videos and read some of my articles on this topic, and I hope that you have found some interest. But I also realize that some of you may lack the basic knowledge about the logical thinking process, therefore I propose this crash course. It is not intended to turn you into experts, but just to give you enough elements to feel comfortable enough to follow the explanations and understand a bit of the conventions and jargon used in this discipline. Let's get started. The first thing you need to know is that we are dealing with two distinct kinds of logic. The first is called necessity-based logic and the second is called sufficiency logic. In the case of necessity-based logic, some prerequisites must be fulfilled in order for the effect to happen or the objective to be achieved. In case of sufficient logic, it is enough for the cause to exist to create the effect. As an example, in order to use my pen, I must grasp it. The pen lying on my desk will not appear magically in my hand when I want to write, so I need to pick it up first. Picking up the pen is the prerequisite that allows me to write with it. Without this prerequisite, no way to write with a pen. We also use necessary condition as an alternate to prerequisite. If I open my fingers that hold my pen, then it falls. This time it is enough to have the cause, opening my fingers, to have the effect, the pen falling. Necessity-based logic commonly use the sentence in order to have or to achieve, and then the objective, we must, the necessary condition. Sufficiency logic uses if, then we state the cause, then we state the effect. One important thing to remember, in necessity-based logic we are dealing with enablers, while in sufficiency logic we are dealing with triggers. Grasping the pen enables me to write with it, but the writing does not happen just by grasping the pen. Opening my fingers triggers the pen to fall. The fall starts as soon as my fingers stop holding the pen. Now to the graphic conventions. This is an entity. This is another one. Arrows in sufficiency logic have their tail at the cause and their head pointing to the effect. And we read bottom up from cause to effect. If I open my fingers, then the pen falls. Arrows in necessity-based logic have their tails at the prerequisite and their head at the objective. And we read top down, in order to write, I need or I must pick up the pen. When two or more distinct causes can trigger the same effect, they are placed under the effect. In this case, we read, if cause 1 or if cause 2, then effect. If the plant gets excess water, or if the plant gets too little water, then it will die. Either cause is sufficient by itself to cause the effect. Two or more causes may be required simultaneously to trigger the effect. In this case, we deal with a logical AND, which is symbolized by the ellipse. In this case, we read, if cause 1 and if cause 2, then effect. If we have gasoline and if we approach a flame, then we have a fire. Having gasoline alone will not suffice to have a fire. Having only the flame of the match without flammable material will not start a fire. On the necessity-based logic side, we may also need more than one prerequisite to enable our effect, but conventionally we are not using the logical AND connector. We read, in order to build a house, I must have building material on one hand, and in order to build a house, I must have a valid permit, at least if I follow the local rules. The rationale here is that the AND is implicit and visible in the diagram, so no need to overload the drawing. Let's move on to more complicated logic structure like the trees. Logic trees are diagrams made of a series of necessary conditions, in case of necessity-based logic trees, and series of cause and effect in the case of sufficiency logic trees. The diagrams look more or less like trees. This is one, this is another one. The logical thinking process has 5 different types of trees and the cloud. Logic trees and clouds are tools, each type having a distinct purpose. The first of them is the goal tree. It is necessity-based. We use it to identify and list all necessary conditions for achieving a goal. It can do a lot more than this, but for the time being, keep this in mind. We build it top-down, from the goal to achieve on the top to the first necessary conditions at the bottom. We read a goal tree bottom-up, as all the necessary conditions must be fulfilled layer after layer until achieving the goal. Second comes the current reality tree. It is sufficiency-based. It is a great tool to drill down from the current situation, the problem symptoms, to the critical root causes, and therefore it's a great tool for problem solving. It is built top to bottom, from the symptoms to the root causes, and we read it bottom up to demonstrate the chain of causation that lead from the small number of critical root causes to the several undesirable effects, which are the visible symptoms of the problem. The next tool could have been a tree, but for some poetic reason it became a cloud. It is nevertheless built on necessity logic. It is used to solve conflict or dilemmas. The building can be done top to bottom or bottom to top, and because of its specific structure, it's not really relevant. Reading should be done from the common goal to the prerequisite of each branch. Next comes the future reality tree. It is built on sufficiency logic. It is used as a tabletop simulator in order to probe our solutions before implementing them. It is built bottom to top, and the reading is bottom to top as well. Next we have the prerequisite tree. It is built upon necessity logic. It is used to overcome obstacles and to drive the required changes. The building is top to bottom, and the reading is top to bottom as well. The last one is a transition tree. It is built on sufficiency logic. It is a step-by-step action plan that should be built bottom to top and read bottom to top as well. But this tool has proven not very useful, and most practitioners do not use it anymore. For learning more about these logic tools and how to use them, I suggest you check my dedicated playlist on my YouTube channel, as well as my logical thinking process articles on my blog. The link is provided in the description of this video. I do hope that you have found some interest and value in this video. If so, please give a thumb up and share it. Until next time.